Okay, so let's look at graphing impulse. So for example, let's say you have a graph like this. Time, force. Okay, let's say this was 80 newtons. Let's say this was 5 seconds. And I asked you, what is the impulse? Okay, so probably your first reaction would be to say, oh, well, impulse is force times time. So when I look at this graph, the force is 80, the time is 5. What's the impulse? 200. Okay, you might say 400 because it's 80 times 5. However, 80 times 5 is 400, but that's not the right answer. What would that mean for it to be 80 times 5? What's happening with the force here? Yeah. It's increasing, it's changing. And so for it to be 400 impulse, that would mean you're applying an 80 Newton force for 5 seconds. Exactly 80 for 5. However, we're not applying 80 for 5. In fact, we're only applying 80 at the very end. Most of the time it's less than 80. So 10, 20, 30, 40, all the way up to 80, right? So to do this, what do? Okay, we find the area under our curve. Good. So the area under the curve FT graph is the impulse. Okay, it's also the change in momentum because the impulse is change in momentum. But so we would find the area underneath this. Okay, so let's just do it real quick, right? It's a nice triangle here. What's the area under this curve? Well, 1/2 5 times 80 gives us how much? 200. And that would be our impulse here. That would be our change in momentum, would be 200. Okay, remember, this is just kind of a general rule for graphs. When you have like an x times a y-axis, x times y, x-axis times y-axis, then finding the area gives you important information, right? When you have something like f over m equals a, then what gives you important information? Finding the slope. So keep that in mind when you're trying to interpret graphs, especially if they pop up a graph you've never seen before. Keep that in mind when you're trying to solve these. Okay, I do want to just point out just kind of a similar graph that we've seen before. Let's say you have an F times D, F versus D. Okay, so what does the area of this going to tell us? Well, first of all, that would be F times D, right? Area would be our FD. And what is what FD? Work. Okay, so notice the area of an FD is going to be work. The area of this, of our FT, is impulse. And what is impulse? Change in momentum. You will remember what work is? Change in kinetic energy, right? So notice these are very similar looking graphs, and they tell you similar things but slightly different things. So this would give us our impulse. It also give us our change in momentum. This would give us our work. It also give us change in kinetic. And in both of these you could find, for example, the final velocity of something. So I think we have time to do that. So let's do